right, we're going to go on to the next section, which is 9.2, two means of independent samples. So you actually know this one again. It's two independent samples where sigma 1 and sigma 2 are not known and not assumed equal. We're actually going to assume that they're equal, but they're unknown. So what kind of test do we do? If we don't know sigma, this is going to be a t-test, but we're looking at two means. Okay, so the first thing you have to do is if they look at they're independent or not. So two samples are independent if the samples from one population are not related or to somehow naturally paired or matched with the sample from the other population. So that's when two things are independent of each other. So two samples are dependent or consist of matched pair, which was one of your samples collecting data, if you remember that. If the sample values are somehow matched, where matching is based on some inherent relationship. And I'm gonna go do an example of each. If two samples have different sample sizes, okay, with no missing data, they must be actually independent automatically. Okay, they can't be matched pair if there's different sets of data. If two samples have the same sample, the samples may or may not be independent. So like an example is if I looked at females randomly and I have 7, and I looked at males and there's like 9. They're automatically independent of each other because there's different numbers. Here's another example of dependent and dependent samples. So independent sample is a height of men and women in data set 1, the body data in Appendix B, includes the following heights, so not all of them, of samples of men and women. The two samples are not matched pair according to some inherent relationship. They're actually two independent samples. They just happen to be listed in a way that might cause us to incorrectly think that they're matched. So if you look at this, it looks like they're matched pair, but it's just women and men randomly. Okay, so they're just organized that way. But here's an example of husbands and wives. Okay, so the author collected data consisting of heights of husbands and heights of their wives. So here's the key thing. Like, if you think about it, they are paired together. 5 of those pairs are listed below. These two samples are dependent because the heights of each husband is matched with the heights of their wives. And usually the husband is taller than the wife, most likely. And if you look at this data, that is true. Okay, so I'm gonna go ahead and match these up together. Whereas these are not matched pairs, they're actually independent. So inference is about two means or two independent samples. We're gonna, again, do some notation for the first data set. I'm not gonna write first data set, I'm just gonna write, well, maybe I will for the first one. So we have mu1. What does that stand for? That is the population mean for first data. Okay. So I'm just not going to write first data, but it's essentially the same thing. So sigma 1 is going to be the population standard deviation for first. Okay. Same thing for N1, sample size for first data. Okay, and then we have X1 bar, which is the sample mean for first. And the last one is S1, which is sample standard deviation for first data. Now, if we have all these for one, guess what? We're gonna have the same for the other one. So I'm gonna write same for mu2, sigma 2, N2, X2 bar, and S2. Again, I'm not going to write them all out, but essentially it's the same thing. Okay, so let's go ahead and check the requirements. What are the requirements, if you remember, for mean? Okay, and you're like, oh my God, it's the same thing. All right, so requirements. The first one is it has to be an SRS for both. Okay. The second one is, again, the same thing. Since it's two data sets, we're going to say independent of each other. And our third thing is it says normally distributed. For both Like if one says it and one doesn't, then you have to check the second one and so on. We're going to do an example of one of these kinds of questions. N1 has to be greater or equal to 30 and N2 has to be greater or equal to 30. Now, if the first one said normally distributed and the second one didn't, but the second set of data is greater or equal to 30, you can just write like one of each of those. So if you remember, like there's 3 criteria for this. So what's the third criteria? Well, if none of these work, you actually have to draw a box plot and say no strong skewness. No strong skewness or outliers. And you have to do this for both, okay? Both data sets, okay? So I'm gonna write a little note since we're doing a t-test, since we don't know what sigma 1 and sigma 2 are, we are going to assume they are equal. And what does that mean? Well, we're just using our HO as our equal sign, which we've been doing all semester. So we are going to assume they're equal. Okay, so all this is that we're essentially saying they're equal because we don't know what they're, okay? All right, so it says test statistic for 2 means independent samples of HO is mu1 equals mu2. Or if you remember, if you move the mu2 to the other side, mu1 minus mu2 equals 0. But I kind of stick with this one. All right, so if you're doing this by hand, what kind of test are we doing? We are doing a t-test. So you're going to do 2 equals, and here's our formula. So usually it's x bar minus mu. It's the same thing, except it's going to be x1 bar minus x2 bar minus mu1 minus mu2. Okay, and assuming, again, if it's the same thing, this is usually 0. All right, all over, and then your standard deviation, which again, formula changes because there's 2 sets of standard deviations, and we don't know what sigma is, so we're gonna stick with S. So we're gonna do S1 squared over N1. Notice the squared is only to the top, plus S2 squared over N2. And then from where do you go? You do TCDF. Okay, and then you have to list out everything that you have, and then you get your p-value. So once you do this, you get p-value. Now, a little note I do want you to guys make is, do you guys remember this one, degrees of freedom? Now, which one do you use? Do you use N1 or do you use N2? So I'm going to write the degrees of freedom is N1 minus 1 or N2 minus 1. Remember, you take away 1 when you're doing your degrees of freedom. I'm going to make a little note, and it's going to be whichever is smaller is the one you use. Okay, you don't do both of them, you just say which one's smaller. So if I have a sample size of 7 and a sample size of 5, I'm going to use 5 and do 5 minus 1, which is 4. Okay, if this is by hand, what do you use by calculator? Well, if you look through the tests, you can kind of figure this one out as well. It's going to be a 2-sample t-test. Okay, and then what are you going to do? You're going to tell me what test you're using and write out everything. Okay, so again, it's pretty much the same notes as the last chapter, except now it's looking at 2 sets of data. All right, so confidence interval estimation, excuse me. Sorry, my notes are a little everywhere. So if you're doing this by again hand, you're gonna do x1 bar minus x2 bar, and you're gonna add and subtract your e value, okay? How do you find your e? That's a great question. So your E is, well, this time we don't have Z, so it's going to be T of alpha over 2, okay, times the square root of S1 squared over N1 plus S2 squared over N2. And that's how you find your E, and it's, again, the same thing essentially. Okay, this is to estimate mu1 minus mu2, if you wanted to look at it like that. If you're doing this by calculator, you're going to be doing a 2-sample t-test, okay, and then you're going to write out everything, and just don't, every time you find confidence interval, don't forget to write your sentence. Okay, so let's go ahead and do an example. I have lots of examples after this. There's 1, 2, 3 examples for this section, and that's pretty much the end of these notes as well. So listed below are students' course evaluation scores taught by a male and female professors. Use a 0.05 significance level to test the claim that the 2 samples are from populations with the same mean. To test the claim that the samples are of the same mean. Does there appear to be a difference in evaluation scores of the courses taught by female professors and male professors? Okay, so we're looking at to see if they have the same mean. Okay, so notice this is data. They're not the same number, so we can actually assume that they're independent. We're gonna have to write this out in a list. So we're gonna make this L1 and this L2. All right, so let's go ahead and start with the state part. Okay, so we're gonna let's go ahead and we'll let females be mu1 and this mu2. Okay, so we're gonna say, so our state, I'm gonna say mu1 equals mean female course evaluation scores. Evaluation scores. And then I'm gonna make mu2 equal mean of male course evaluation scores. Okay. What is going to be our hoe? Our hoe is that mu1 equals mu2. And our ha is going to be mu1 is not equal to mu2. Okay, because they're just saying the same mean. It doesn't say, is there a difference in the scores? Like, it doesn't say less than or greater than. We're just saying, is there a difference? Okay, so that's your state part. Let's go ahead and do our plan part. Okay, well, since this is again taken from the book, I'm going to say this is SRS for both. Because I'm going to say from book. Okay, but yeah, they're both good to go. I'm going to say they are independent. Why are they independent? Because we're looking at gender and like of professors. I don't think that they're related to each other. I hope not, at least. And then we're going to say N1, which is our first set of data, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so N1 is equal to 12, which is not, it's less than 30. And N2 is 13, 14, 15. 15, which is also less than 30. Okay, so we're actually going to have to graph this since they doesn't say normally distributed. They're not greater or equal to 30, and yeah, so we're going to have to graph both of them. So that's why I wrote this in L1 and this in L2. So I'm going to go ahead and type in the female data in L1. I have to clear this data real quick. I'm going to say 4.3, 4.3, 4.4, 4, 3.4, 4.7, 2.9, 4, 4.3, 3.4, 3.4, 3.3. Okay, and I got 12 numbers, so far so good, and I'm going to do the same thing. So 4.5, 3.7, 4.2, 0.9, 3.1, 4, 3.8, 3.4, 4.5, 3.8, 4.3, 4.4, 4.1, 4.2, and 4. Okay, so I got everything in my lists. We're good to go. We're going to go ahead and draw a box plot for both. So I'm just going to go to second stat plot, turn the first one on, and then I'm going to do the second one. I'm going to actually turn this one on as well. I'm going to use L2, and I'm good to go. And if you remember, you hit zoom 9. And I have something written, so I can't do that. There we go. Zoom 9, and there you go. I have my 2 ones, so I'm going to go ahead and sketch both of them. I'm going to label both of them. I'm just doing a sketch. Again, it doesn't have to be perfect. Okay, so I'm going to use L1 if you go back to this. So if you go to this one, this is going to be your male because it's in the bottom, and this is female. And the way I know this is like the blue one is the top one, which is male or female. And so I'm just labeling it female and male, and I'm going to just say no strong skewness. And yeah, they're a little skewed, but they're not like really skewed. So no strong skewness and no outliers. Okay, so all conditions are met. Good job. So I'm going to just write all conditions are met. You don't have to write this part. I just writing this for you. If you're like copying the notes, you can be like, oh, okay, they're all met. Okay, so let's go ahead and do the do part. Again, I'm going to do this by hand. I'm going to do this by calculator as well. Okay, so let's go ahead and do this by hand. So we're going to do T equals, I like writing the formula out the first time. So x1 bar minus x2 bar minus mu1 minus mu2 all over the square root of S1 squared over N1 plus S2 squared over N2. Okay, so let's go ahead and plug some numbers in. So x1 bar, and how do I find what the average is? You can do a 1 var stat for them. So I'm gonna do that. I'm gonna do edit, calculate 1 var stat, and use list 1, and I can write out what the mean and stuff are. Okay, so again, how I did that, I just did a 1 var stat, which means 1 variable stat, is I did stat, calculate 1 variable stat. And I got my information. So if you want to write it down, you can. I might just write it down actually. So x1 bar was 3.867. I need s sub x, which is really s sub 1, is 0.563. I don't need sigma because this isn't sigma. And that's really all I need from that one. And then I have to do the same thing, and my n1 is 12. I already knew that, but... And then I'm going to do the same thing for the second variable. I'm just going to change this to L2. And I'm going to do x2 bar equals 3.993. S sub 2 is, let's see, 0.395. And N2 is 15. Okay, so I'm just going to write it down here because when you get to this part, I can just kind of copy it down. Okay, so I have x1 bar, which is 3.867 minus x2 bar, which I got as 3.993, minus 0, because assuming we usually use this as 0, all over the square root of s sub 1, which was 0.563 squared, over n1, which was 12, plus s sub 2, which was 0.0395 squared, 0.395 squared. 0.395 squared over 15. I'm going to go ahead and use my calculator and see what I get. So I have to quit, sorry. It's going to be parentheses 3.867 minus 3.993, parentheses, divided by square root of 0.5632 squared divided by 12. Plus 0.9395 squared divided by 15. And it's all in a big square root, and I'm really glad that's what I got because that's what I'm supposed to get, negative 6.57. Okay, this is your t-score. What do I have to do now is I have to find my TCDF. Okay, and so since this is negative, we're automatically going to go negative 1,000 to negative 0.657. Now my degrees of freedom. Okay, well, I'm going to look at this. Remember, it's n minus 1, but it's the smaller one. Okay, so my n minus 1 in this is either going to be 15 minus 1, which is 14, or 12 minus 1, which is 11. So which one's smaller? We're going to say 11 because this is 12 minus 1. Okay, and so I'm going to do TCDF to find my p-value. So I do lower is negative 1,000, my upper is negative 0.657, and my degrees of freedom is 11. So I'm going to say this is lower, this is upper, and my degrees of freedom is already labeled as DF. Okay, and so this is 0.262, but remember this right here is only your one tail. This is a two-tail test, so I actually have to multiply this by 2. And so when I do that, I get 0.525. I know when you multiply this one you don't, but I just wrote my answer. That's close enough. This is your p-value. Okay. All right, that's by hand. Let's go ahead and do this by calculator. So if you're doing this by calculator, you are going to be using a 2-sample t-test. So I'm going to go ahead and do that. List tests 2-sample t-test. Okay, now you either have your stats, which you wrote down, you can type in, or you can go to data and just say list 1 is where the first data set is, but for me I have to change this to list 2. So I'm just going to write list 1 is L1, list 2 is L2. Frequencies I don't have to write out, but I do have to write mu1 is not equal to mu2. Now pooled. Here's the thing, pooled only works with proportions, not with mean. So pooled, I'm gonna say no. And then let's go ahead and hit calculate. And so I'm going to write my t value to be negative 0.660. My p value is 0.517. And I think that's all I have to write because everything else was given to me. Okay, so that's all I have to write for here. I should write my degree. I know my degrees of freedom is a little weird. There's a little formula to it. So 0.0196063. Okay, so let's go ahead and write our conclude. We're going to write P equals, well, in this case, they're pretty close together. So I'm just going to pick 525 is greater than alpha. We fail to reject ho. There is no sufficient evidence that what? Well, if we're failing to reject ho, that means we are accepting it. That means that there's no sufficient evidence that there is a mean difference in evaluation scores of male and female professors. Okay. All right, and that's an entire one question. I know it's a lot. That's why your homework is actually not that long. All right, so let's do another one. I think I have 2 more left. And again, you're more than welcome to pause the video. You can just kind of do the, try it out on your own. So this is the same question. It says construct a 95% confidence interval to estimate the difference between the mean course evaluations for females and then mean for males. Okay, so just really quick, let's go and write out the formulas. Again, I'm going to do this by hand, and then I'm going to go ahead and do this by calculator. So by hand, it's x1 bar minus x2 bar plus or minus your e. So if you're doing this by hand, your e is going to be your t of alpha over 2 times the square root as s1 squared over n1 plus s2 squared over n2. Okay? And then if you're doing this by calculator, and I'm just going to write this, is going to be a 2-sample t interval, or a t int. Okay? All right, so let's go ahead and do this by e. So right here, if we're doing a 95% confidence interval, we're going to go ahead and use a degrees of freedom on our slower level. So to find this one, if you remember, it's inverse t and asks you for the area. So remember, if it's 95%, that means that there's 5% left. That means on each side is 2.5%, which is going to be 0.025. And our degrees of freedom, we're going to go based off of the smaller value, which is 11. Okay, so I get, negative 2.200, if you want to look at it like that, 0.001 actually. Okay, so let's go ahead and plug things into our formula to see what we get. All right, so I'm going to do, it doesn't matter about the negative, so 2.201 times the square root as s sub 1. I shouldn't have gotten rid of that paper because it had all the numbers on it. S sub 1, which was 0.563 squared over n1, which was 12, plus 0.395 squared over 15. Okay, and again, we're doing this by hand, and we're going to do this by calculator, so you can kind of see what we're up to. So I'm going to do 2.201 times the square root of parentheses 0.563 squared divided by 12 plus parentheses 0.395 squared divided by 15. And I'm just going to write this number down, 0.4223. I'll just do 4 decimals. It's fine. I already did it. Okay. So let's go ahead and write out our x1 bar minus our x2 bar plus or minus 0.4223. So again, on the previous page you wrote out, and this is just from our data from the last one. So our x1 was 3.867, and our x2 bar was 3.993, and then we're going to add and subtract 0.4223. Okay, so I'm going to write this out. 3.867 minus 3.993 minus 0.4223. Okay, and I'm going to do the same thing for plus. And I have my interval. I have negative 0.548 and then 0.296 as my answer. Okay, now if we're doing this by calculator, it's actually the same thing. I'm going to do stat tests 2 prop t int, and I'm going to use my data. And again, I'm going to write out my information. So I'm going to write list 1 is L1, list 2 is L2, and then my C level is 95% or 0.95, and then it's pooled, it's going to be no. So remember, pooled is only for proportion. Okay, so I'm going to go ahead and calculate, and I'm going to write out the value. So I have negative 0.676 and then 0.4223. Why is it so off? Degrees of freedom is 19.063. Did it right. Let me make sure I did it right. Sample test 2 prop z 2. Oh, I did 2 prop maybe. 2 sample t int. Oh, I hit 99. It should be 95. I messed up. There we go. That's a better answer. So I just wrote the wrong. So negative 0.528 and then 0.275. Okay. And then my degrees of freedom is actually the same thing. I now have to write the information out because it's pretty much the same question. So here's my little thing I wanted to talk about. If you look at this, is 0 included in here? And the answer is yes, it is. So since 0 is included, so I'm like, since 0 is included, we are actually going to fail to reject hoe. That means we're going to accept the hoe, meaning our hoe, since it's included, is actually inside it. Okay, so since it's inside, we actually fail to reject it, meaning we accept it. Okay, that's just like a random, I did want you guys to include it. Now, since we're asked to find confidence interval, what do we have to do? We have to write a sentence. So we are 95% confident that the interval from negative 0.548 to 0.296 contains the true mean, of the difference between male and female professor course evaluation. So male and female professors evaluation scores. Okay. All right, so again, I wrote a lot bigger because I had a lot of space, but I'm gonna go ahead and go on to our last example for these set of notes. Again, if you wanna pause it and try it out on your own, you're more than welcome to. I'm not going to do it all. I'm just going to kind of do part of it. So it says a headline in USA Today proclaimed that men and women are equal talkers. That headline referred to a study of the number of words that men and women spoke in a day. Using alpha equals 0.05, test the claim that the mean number of words spoken is the same for men and women. Here's a little key thing. If it's the same, that means your ha is going to be it's not the same. Okay, so using the men and women randomly selected. Great. So first of all, let's go ahead, and we don't know what sigma is, so we're going to leave that alone for now. Let's go ahead and write out what our state is. So what is mu1? Well, you kind of have to set aside, since this is already kind of labeled, I'm going to assume that goes with this. So I'm going to write mean amount of words spoken by men. And mu2 is going to be mean amount of words spoken by women. Okay. What's my ho? Okay, my ho is mu1 is always equal to mu2. And what's my ha? Well, they're saying that they speak the same, so we're going to say that they're not. So remember, this is a two-tailed test. Okay, so let's go ahead and plan it out. Okay, these men and women were randomly selected, so both SRS. They are independent. Independent. I'm just gonna write gender. They're not matched pair. Okay, and then I'm gonna assume that, like, well, in this case, I'm gonna say both N1, which was 186, is greater or equal to 30, and N2, which is 210, which is greater or equal to 30. So all conditions are met. Notice I didn't have to check the NP because that only works with proportions. For this one, you didn't have to. Okay, so for your do, you can again do this by calculator or do this by hand with the TCDF. I'm just gonna go ahead and write 2 sample, I'm gonna do this by calculator, 2 sample t-test. Okay, so I'm gonna go ahead and go to 2 sample t-test and I'm gonna type in what I have to use. So 2 sample t-test, it's the 4th one. All right, so this time it's not data, it's actually stats. Okay, and I have to clear data out as I write. So X1 is 15,668.5. So I'm gonna write 15,668.5. S1 is 8632.5. So X32.5. N1 is 186. X2 bar is, let's see, 16,215. S sub 2 is S sub 2 is 7301.2. And 2 is 210. And our mu1 is not equal to mu2. And is it pooled? I'm gonna say no. Okay, and I'm gonna go ahead and write out what I get. So I don't have to write the mu1 is not equal to mu2. I'm gonna write my t-value is negative 0.676, and my p-value is 0.50. It's very close. And my degrees of freedom, again, is 364.259. Okay, and I don't have to write the other info out. Again, if you do this by hand, you're gonna get very close to these answers. You might not get the same answer. Your degrees of freedom is actually gonna be 185 because you're just going based off of the smaller number. I really don't know how to get this one. I just write it down. Let's go ahead and write our sentence. I'm gonna write conclude. All right, well, if our alpha is 0.05 and our p-value is 0.50, don't get them confused. I'm gonna write p-value is equal to 0.5, which is greater than alpha, so you fail to reject Ho. I'm going to say there is no sufficient evidence that what? That the number of words spoken, that the mean number of words spoken is not the same for men and women. And that's the end of 9.2.